Hello everyone. My topic for today's presentation is deriving intents from users' queries using BERT. These are the tasks I'm going to discuss today in the presentation. So the problem statement is the intent recognition or the intent classification. It is a process of taking a written or spoken text and classifying it according to the user's query. It is a natural language processing task. It enables the system to guide the conversation in the right direction, respond to the queries from the users, and carry out the actions they desire to perform. As we can see in the figure, like for example, book a restaurant at 16 o'clock in the Toronto, book me a table for 7 people at the bar with the pool. These are the intents. These are the sentences, and the intent detection model will give the output as the intent book restaurant. And other example is, for example, the sentence is like, how is the weather in Thunder Bay? Will it storm in the Charles Pickney National Historic Site? And the intent of these sentences is get weather, as we can see in the figure. So the purpose of this project is to extract the semantics from the user messages and assign them an appropriate label. It is a classification task done by using a pretend deep learning BERT model. BERT is significant because it is bidirectional and can learn the information from both left and the right side of the token's context during the training phase. It understands the intents behind the user's query so that exactly to the point searches can be presented to them. Intent recognition is used by a variety of help centers, chatbot, automatic email responders, and response recommenders to eliminate the need for large number of staff to copy and paste the dull answers to commonly asked queries. It is also integrated with a chatbot using AWS Slack services. So the related work and challenges. So in the past, the intent classification systems relied on keywords or context-free grammars. Many deep learning algorithms such as CNN, LSTM, attention-based CNNs have recently been investigated. And so, but to obtain the state-of-art performance, these techniques typically require huge level datasets. So it becomes very difficult to handle such dataset if they are not in the proper format. Now an efficient and a new pretend language model called BERT has been developed. And due to its bidirectional representation on words and fine-tuning, it produces the best results in comparison to the previous models. So the methodology for intent detection tasks, generally we are going to do in two stages: text representation, and the second one is the text classification. Text representation means like unsupervised pre-training models have excelled in a variety of natural language tasks, including word-to-vector, ELMO, and BERT. These models are used to perform text representation tasks. Among them, BERT learns more precise and full semantic knowledge. And in BERT, the input is the sentences, and it then converts into the tokens and adds the two special tokens, CLS and SCP. CLS token is added at the beginning of the sequence, and SCP token is added in the start and end of the second sentence. Now, second one is the text classification. Text classification mostly involves the models based on CNN, RNN, LSTM, GRU, and among all, but outperforms them as it has two main features, or you can say that it is trained on the two tasks, that is mass language modeling and next sentence prediction. So in mass language modeling, some of the words are masked so that the model can identify the missing word, and in next sequence prediction task, uh, the model is able to identify the word that comes next to the previous word in a sentence. So BERT stands for bidirectional encoder representation from transformers. BERT is a pretend transformer based encoder stack. It is trained on Wikipedia articles in book corpus dataset for a variety of tasks such as question answering, text summarization, natural language inference, and many others. As we can see, there are two types of architectures of BERT, namely BERT base and BERT large. We are going to use BERT base model in my project. In the specifications of the BERT base are, it has 12 layers, and the size of the hidden layers is 768, and the self attention heads are 12, and total parameters are 110 million. So we can see that it is quite pretend on a very large data. The dataset we are going to use in this approach is a SNPs dataset. The data contains various queries categorized into 7 intents. It contains the training set, validation, and test set utterances separately. It has total 13,784 training examples and 2 columns, that is text and intent. So the various phases involved in this project are as follows. The first one is the pre-processing. To employ the pre-trained BERT model, we first need to transform the input data into the acceptable format. For this, we need to do pre-processing of the data. So pre-process generally follows the 3 basic rules. First one is to tokenize the text, convert the sequence of tokens into the numbers as shown in the figure, and fill the gap between the sequence so that the size of all of them have the same length. Second one is the fine tuning. Fine tuning means using the already trained task, and you use that model to in the project that is not already trained, like you use in the similar task. So we must need to make the BERT usable for text classification by loading the model and attaching a couple of layers, keras layers on it. The pre-trained BERT model is fine-tuned using the inputs, that is the text and the intent, and then the activation function like softmax is applied, and we get the desired output. For the training purpose, I have kept the batch size of 16. Learning rate is 10 raised to minus 5 with Adam optimizer, and the number of epochs is 5. As we can see that the model is able to train and give the accuracy of about 98.84% with a very little loss in both training and the validation set, as we can see in the figure. Now also this intent recognition project is integrated with a chatbot. So I have made a chatbot with the help of Amazon Lex service. So Amazon Lex is a service for building conversational interfaces into any application using voice and text. Amazon Lex provides automatic speech recognition for converting speech to text and natural language understanding to recognize the intent of the text to enable the build applications with highly engaging user experiences. So in this we have to give the sentence as input, and the bot will reply with the intent related to that sentence. In the evaluation part, as we can see that the training accuracy is obtained is 99.15% and test accuracy is 97.71%, which is very impressive. Also, a classification report has been made which contains the precision, recall, and the F1 score, and we can see that among all the 7 intents, the results are from between 95% to 100%, and the weighted and after overall the weighted accuracy obtained is nearly 98% in all the intents. And the first graph shows the loss versus epoch graph, and we can see that as the number of epochs increases, the loss in the training phase decreases, which tells that the model is working better and giving better results. The second figure shows the accuracy versus the epoch graph, and we can see that as the epoch increases, accuracy also increases, so our model is training well. And this is the visualization of our data, and you can see that there are 7 intents, and the number of intents are represented on the y-axis, and the second figure shows the final output we obtained on the custom queries. Like if we give the text play our song, its intent will be play music. So this model also works well on the custom sentences. This is the chatbot I made called intent bot in AWS, and the as I like in the textbook you can type a message. If I write a query like I want to book a restaurant, and the bot will reply with book restaurant as intent. So the resources required is Python 2.7 or 3.5 and greater than that version, Google Colab to run our code with the GPU, and the RAM requirement is only about 100 to 200 MB of RAM. And the figure shows that the Gantt chart, that means that our this project will work of around 2 months, and these are the various phases included in the project. For the future work, This work is only of intent recognition, which can tell the semantic behind the user's query. It can provide the intents from the custom sentences, but not only from only from the 7 intents, not from any other. So in the near future, more intents needs to be added and make into some domain specific, like for example, restaurant. Like if we make intent recognition and integrate it with the chatbot, with in any website or application related to the restaurant, we need to add more intents and sentences that will be required for the intent. So in conclusion, I would like to tell that our model worked very fine to overcome the existing NLU model's low generation capacity, and the proposed approach will be tested on a very large scale and complex NLU dataset in the future, as well as usefulness of merging with some information with the bird. So intent recognition technique can be applied to the chatbot so that they can easily understand the main idea of the user from the sentences and drive the conversation to the right direction. These are the references. Okay, thank you.